The UK railway industry is upgrading thousands of miles of track in a massive investment programme. In recent years, they've wanted to accelerate the programme while introducing greater efficiency. They asked their suppliers to rise to the challenge, find a way of getting more rail delivered trackside faster than ever before. Cowans Sheldon came up with a solution. Welcome to the world of Langley Holdings, a British multidiscipline concern which provides world-class engineering to world-class clients. The Clark Chapman Group, a Langley company, is known around the globe for one of the most famous names in the railway industry, Cowans Sheldon. Its association with rail dates back to 1866, when it built one of the first ever railway cranes. It's been known for engineering innovation ever since. By the mid-1980s, the company responded to the need for major track refurbishment in the UK by producing a long welded rail delivery system capable of placing rail measuring up to 183 metres alongside the existing track. The system carried 24 lengths of rail at a time and took 5 hours of track possession to carry out the operation using 4 or 5 operatives, a significant improvement on previous systems. However, as the new millennium approached, requirements were changing. For a start, demand for rail replacement was increasing dramatically, up to 144,000 tonnes a year as a result of increased traffic and infrastructure improvements. Network Rail's new long rail welding facilities are capable of producing longer lengths of rail than the old system could handle, and there was a drive for increased efficiency in both manpower utilisation and delivery performance. With the old delivery systems approaching the end of their useful lives, the pressure was on to create a new breed of long welded rail trains. And this is it. Cowans Sheldon's latest rail delivery train, capable of carrying rail lengths up to 216 metres as opposed to the previous 183, carrying 32 rails rather than 24, a 57% increase in capacity, requiring only a 3-hour possession to do the delivery rather than 5, and manned by 3 operatives rather than 4 or 5, with the potential to reduce to just 2 operatives in a new fully automatic version. All this, and it's reliable, simple to operate, and safe. The next generation of RDTs was conceived by a dedicated team of railway specialists at Cowans Sheldon, who drew on known technologies in steel, tyre manufacture and other material handling industries, incorporating the mechanics and computer-controlled systems which had a history of reliability and maintainability. It's significant that the system was both designed and manufactured at Cowans Sheldon's factory in the northeast of England, with its long tradition of innovation and engineering excellence. The Gateshead factory has an experienced multidisciplined workforce, well used to converting a concept into a reality, using the latest technologies and skills backed up by rigorous quality assurance. The facility is well equipped to assemble world-scale projects like this. And this is how it works. After loading and securing the rails onto the train at one of the long welded rail facilities, which are strategically positioned on the rail infrastructure within the UK, the delivery train is hauled to site at 60 miles or 96 kilometres an hour by a locomotive which is then utilised for low variable speed to deploy the rails to trackside to a maximum operating speed of 5 miles or 8 kilometres an hour. The system is designed on a modular concept, with all the equipment being mounted on a standard ISO container base. This allows the utilisation of standard container wagons and offers enhanced operational flexibility. The system carries a maximum of 32 continuously welded rails up to 216 metres long. The rails are supported on 4 tiers of 8 low-friction flanged rollers along the length of the train. For safe network transit, each rail is retained in a quick-release screw-driven clamp over 2 clamping wagons. 24 conductor rails can be accommodated in a different configuration of 4 tiers of 6. Obviously, shorter lengths of rail can be accommodated within the configuration of the train. On reaching the worksite, the modular manipulator and unloader are used to manoeuvre the rails following unclamping from the roller banks down into the unloader roller drive units, where they are then powered hydraulically through and down the deployment chutes on the final wagon in the system. The manipulator cycle and chute deployment are both automatically controlled by a process logic controller. When the rail ends have been accurately positioned using the rail handling equipment into either the 4-foot or 6-foot positions, the chute operator and train controller instructs the locomotive driver to accelerate to 5 miles or 8 kilometers an hour. As the train begins to move, the computer system matches the unloader drive unit to that of the train speed through digital encoders to enable the rails to be deployed to the trackside. In the semi-automatic version, the quick-release clamps are manually operated, while in the fully automatic version, the clamps are remotely released by the manipulator operator. The whole process is highly automated, making the operation simple, and it's highly reliable because the technologies involved are proven. It's also been designed with safety in mind. There are less people involved, and those that are remain in safe areas of the system. No one will be trackside, although in these trials operatives were positioned trackside to observe the operation. The whole life package provided by Cowans Sheldon to Network Rail, who have ordered 8 systems in total, includes a comprehensive maintenance support service. Significantly, if failure of a component takes place or damage is caused during operation, the RDT has been designed with modular units in mind, so the module involved can be easily removed and replaced, ensuring the system remains fully functional while repairs or maintenance takes place elsewhere. It's all part of a total package from Cowans Sheldon, coming up with a solution to an industry need through world-class engineering delivered to a world-class client, and building on a mutually beneficial long-term relationship, which just happens to be the mission statement of the Langley Holdings group of companies. Mission accomplished. Now for the next challenge. Welcome to our world.